Hello, thank you for the chance to given to me. First of all, let me introduce myself. I am Hasim Zainur Iksan from Department of Agri-Technology, Faculty of Agriculture, Universitas 11 Maret. In this opportunity, I would like to present about the estimation of above-ground biomass and carbon stock in a pine-mahogany mixture stands at KHDTK Gunung Bromo, Karanganyar. Global warming is caused by the increasing of greenhouse gases concentration in atmosphere such as nitrogen dioxide, methane, sulfur hexafluoride, and hydrofluorocarbon. But the largest greenhouse gases was carbon dioxide. One of ecosystem that can reduce the amount of carbon dioxide was forest. Forest absorbs the atmospheric carbon through photosynthesis and stores it as plant biomass. They has an ability to reduce emissions up to 37% by 2030 to keep global temperature increases below 2 degrees Celsius. Furthermore, Dixon and Clark reported that tropical forests stored 40% of terrestrial carbon total. To understand the contribution of forests to reduce global warming, it was necessary to calculate above-ground biomass and carbon stock. KHDTK Gunung Bromo was an educational forest that managed by Universitas 11 Maret. It dominated by pine and mahogany trees and planted in mixer stands. As we know, pine is a commercial species that produces resin, while mahogany is a woody plant that mainly used for furniture. But it also has an ecological function to absorb carbon from the atmosphere and reduce impact of global warming. There are several research conducted in KHDTK Gunung Bromo such as vegetation and fauna, but the biomass and carbon stock of a pine-mahogany mixture stands in KHDTK Gunung Bromo have not studied yet. So, the purpose of the research was to determine the potential of above-ground biomass and carbon stock in pine-mahogany mixture stands at KHDTK Gunung Bromo, Karanganyar. Our research located in Karanganyar, Central Java, Indonesia, that forest was in altitude 244 to 362 meter above sea level and have 128.5 hectare forest area. Pine mahogany mixture stands were planted in the range of 1991 to 2007. The environmental condition was shown in the table 1. To determine the plot, we used the systematic sampling with random start with distance between the plot were 100 meter, and the plot have 400 meter square area. In total, there were 35 square plots had been set up under the pine mahogany mixture stands. This research was conducted by using non-destructive sampling method. There are two collected data from the field to measure the amount of biomass. We measure the trees with a diameter more than 10 cm by diameter tip. Then we also measure the height of tree with hagameter. This is the flowchart of our research. After we got the data about diameter, height of tree, and number of trees, then we convert into volume with formula 0.25 p multiply with diameter at breeze height, tree height, and correction factor. The correction factor was 0.6. Otherwise, the number of trees were converted into stand density by dividing total individu of species with plot area. Then, to get data about biomass, we multiply the volume with wood density and biomass expansion factor. The wood density for pine were 0.55 and for mahogany were 0.61. Furthermore, the biomass expansion factor for pine were 1.31 and for mahogany were 1.36. After that, we convert into the amount of carbon stock by multiplying the carbon organic. Carbon organic were 0.47. In addition, we also measure the amount of carbon dioxide content with formula as shown in this slide. This figure shows the diameter class distribution of pine and mahogany trees in KHDTK Gunung Bromo. We classified the diameter class by 10 cm interval based on 3 diameter class pine and mahogany trees that categorized as pole with diameter at breeze height 10 to 20 cm was 17.6 and 28.2% from the total tree number per hectare, indicating that those trees might be the latest trees that planted at 2007 by Perhutani as the previous administrator of Gunung Bromo Forest. Furthermore, it was hard to find large diameter trees in KHDTK Gunung Bromo. Based on the obtained result in the present study, in 1 hectare only one tree that belongs to diameter class more than 50 cm. Thus, it was considered that might be those trees was intentionally left behind during clear cutting in the past by the previous administrator. The density of pine were 346 trees per hectare, while for mahogany were 85 trees per hectare. Therefore, total density for pine-mahogany mixture stands were 431 trees per hectare. It was stand volume of pine and mahogany at KHDTK Gunung Bromo. As we see, the highest volume were in diameter range of 30 to 40 cm for pine and mahogany, which was 84.45 meter cubic per hectare for pine and 16.8 meter cubic per hectare for mahogany. The total volume of pine stand were 189.50 meter cubic per hectare, and for mahogany stand were 39.9 meter cubic per hectare. So the total volume of pine mahogany mixer stand were 229.4 meter cubic per hectare. The highest above ground biomass value was obtained from diameter class 30 to 40 cm for pine. On the other hand, the lowest biomass was in diameter class more than 50 cm for mahogany, indicating that the number of mahogany trees that reached diameter more than 50 cm was rare. Then, total above ground biomass for pine was 136.53 ton per hectare. For mahogany, the total above ground biomass was 33.10 ton per hectare. The volume has the largest impact for calculating the biomass. So even though the stand density of diameter class 30 to 40 cm was lower than in diameter class 20 to 30 cm, the highest biomass were in the tree diameter class of 30 to 40 cm. The total stand volume was higher, indicating that larger tree diameter was correspond to the higher values of tree biomass. This is the relationship between tree diameter and above ground biomass. They had strong positive correlation, so the increasing stem diameter was followed by the increasing amount of biomass. The stand biomass has strong correlation to the potential stored carbon. According to IPCC and PSN, the amount of carbon stock were 47% of biomass. Therefore, it was considered that the estimation of stand potency as carbon storage can be predicted from its stand biomass. Thus, by increasing biomass amount will increase the amount of potential carbon storage. Based on this figure, it was clear that the tree diameter giving the most significant effect on the value of stored carbon. The highest stored carbon was also in the range of diameter class 30 to 40 cm. As shown in this table, total carbon stock for pine stand were 64.17 ton carbon per hectare, while for mahogany stand were 15.56 ton carbon per hectare. In total, pine and mahogany carbon stock were 79.73 ton carbon per hectare. We compared the pine mahogany carbon stock in KHDTK Gunung Bromo with Herianto et al. 2010. The total carbon stock of 5-year-old pine and 9-year-old mahogany stand at PKPH Manglayang Barat West Java was 40.86 ton carbon per hectare. So, the amount of carbon stock in KHDTK Gunung Bromo were higher than the amount of carbon stock in PKPH Manglayang Barat West Java. Carbon dioxide uptake by vegetation depends on the photosynthesis and respiration. Vegetation can be thought as carbon absorber if the total amount of carbon dioxide absorbed during photosynthesis was higher rather than carbon dioxide released during respiration. This table shows that total carbon dioxide equivalent for pine and mahogany stand were 235.29 and 57.4 ton per hectare. The amount of carbon dioxide equivalent were varies for each tree species and diameter. For the example, Palosakan reported carbon dioxide sequestration for 17 and 30-year-old pine trees were 318.5 and 354.2 ton per hectare. Then Rosales also reported that carbon dioxide equivalent for mahogany with average diameter pre 25 cm was 68.17 ton per hectare. Rahayu also reported that the average of carbon dioxide sequestration of Eucalyptus pelita were 254.67 ton per hectare. Thus, the carbon dioxide equivalent for each tree species, age, and diameter were varies. According to the data, we can conclude that the tree density of pine mahogany mixture stands were 431 trees per hectare, while the total volume were 229.4 meter cubic per hectare. The amount of above ground biomass were 136.53 for pine and 33.1 ton per hectare for mahogany, with total above ground biomass 169.63 ton per hectare. The carbon stock for pine were 64.17 ton per hectare, and for mahogany were 15.56 ton per hectare, with total carbon stock 79.73 ton per hectare. We also calculate the amount of carbon dioxide equivalent for pine were 235.29 ton per hectare, and for mahogany were 15.56 ton per hectare, with total carbon dioxide equivalent were 292.33 ton per hectare. That's all. Thank you for your attention. If you have any question about this research, feel free to ask. Thank you.